All right. So we are doing rational expressions. There are already 2 videos from Coach Emmons. Those are available for you at gwinnetmath.com. These are, the intention of today is just to review like you've never saw this before. So it's like a brand new basic start of the different things you're going to see. First, one way that you can do your factoring is to look for the greatest common factor. And when we talk about greatest common factor, we're usually looking either at the coefficients, which are numbers, or the variables, which are letters. So when I look at this, first I'm going to do is I'm going to first look at the coefficients. So the first way to do it is greatest common factor. Step 1 is to look at the coefficients. How can you break the coefficients down more? That's what you need to look at. So here, my coefficients are, okay, what does 60 and 12 have in common? Here, my coefficients are 70 and 100. So what does 70 and 100 have in common? Now, if you knew your math tables, you know you can get 1 and 60, 2 and 30, 3 and 20, 4 and 15, and 5 and 12, and 6 and 10. Those are the factors that you have for 60. Now, right away, I notice that this has a 12 here and a 12 here. So because of that, my greatest common factor for my coefficients is going to be 12, because you can't get any bigger than 12, and 12 can go into 60. Here's a tip that I do. I will break down sometimes my smallest number and then try to see what's the biggest of the smallest numbers. So I did the reverse. I broke down the 60 to just remind you how to separate things out. But really, when I do this in real life, what I do is I look at my smallest number, so in this case, the 12, and I see, okay, how many times does 1 go into 12? Then on my calculator, I just say, okay, well, can I do 60 divided by 12? Yep, I can. I get 5. So now I know I can just stop with all the different multiples. When you do greatest common factor, think, what's the biggest things that can go inside? Can those biggest numbers go in? And I'm going to demonstrate that with you for question 2. So now, because I have 60 and 5, I know that really I can take this 60, and this 60 is really saying 12 times 5. And this is really saying 12 times 1. So all I did is first, I did my coefficients. How can I split my coefficients up? The next thing I look at for step 2 is I think, okay, how can I separate out, this is for doing GCF, how can I separate out my variables? And I'm going to do it the long way for this problem, the shorter way for the next problem. Well, here when I separate out my variables, I have, on the numerator, I have x times x times x. And I know I have x times x times x because this says x cubed. So now I can cross this out because really I have x times x times x. All I'm doing is taking the 60x cubed and I'm expanding out the notation. Here I just have simply x. Now the last thing I need to do is I need to reduce the fraction. And we reduce by canceling. So I can see that I have a 12 here and a 12 here. So 12 divided by 12 just leaves me with 1. I notice I have an x in the numerator and an x in the denominator. So that leaves me with 1. And there's nothing else I can cancel because all my denominator is 1. So what I have left is 5, x, and x. That's it. So when I simplify them that, my final answer is going to be 5x squared. Now let's break this down a little easier. Remember, step 1 is the coefficients. Well, I'm going to look at my smallest number, which is 70, and think of the biggest ways I can break it down. Well, I can do 70 times 1. Well, 100 divided by 70 isn't a perfect number. Then I'm going to do, well, 70 divided by 2 is 35. 100 divided by 35 doesn't work. 3 doesn't go into it. 4 doesn't go into it. 5 can go into it. 5 can go into 71. Hold on. 14 times. Well, 14 doesn't go evenly into 100. And then I can do 7 times 10. And then, yep, that's it, because I can do 100 divided by 10 is going to give me 10. So now I know how I can split it up. I'm going to split it up by 10 and 7 in the numerator and 10 and 10 in the denominator. So right here, I'm going to write 10 times 7, and down here, I'm going to write 10 times 10. So I like to keep my numerator, all my work on the top above the numerator, and all my work on the bottom with the denominator. Then this says v squared, so I know that v squared just means v times v, and this is just v by itself. So then I think, okay, I did separated my coefficients, I separated my variables, now I can reduce by canceling. Well, I see I have a 10 here and a 10 here, and 10 divided by 10 is 1. And I can't do anything with the 7, and I notice I have a v here and a v here. So that means that after I do my canceling, I'm left with a 7, a v in the numerator, and a 10 in the denominator. So my final answer is 7v divided by 10. So that's the first thing. The first way that you could do factoring is to solve and look for the GCF. The second way that you can do factoring is by actually breaking out the trinomial. Now, there's different ways your teachers have taught you how to divide out the trinomial. So let's take a look. First of all, here we have m squared plus 4m minus 21. Here are some tips. This is how I do it. I look at this symbol right here. That means that when I multiply by my binomial together for my last step of FOIL, I need to get a negative number. So the only way I can get a negative is if one of these are positive and one of these are negative. So in this case, I know my binomial is going to have one positive and one negative. And I know that because I know when I multiply my last term, I need a negative number. So I need one positive, one negative, like this. Now, the next thing I do is I notice the symbol that is in front of the b term. I notice this. This tells me that my biggest number inside of the binomial is going to be positive. And I know that because when I do my innards, I don't know why, yeah, that is an S. When I do my inner part, basically what happens is I have to add. So when I do the outer plus the inner, they have to add to a positive number. So because that's positive, my biggest number is going to be positive. So let's write that down. First, we know we're going to have a positive and a negative. And we know that this is going to be the biggest number. Now, next, I'm going to look at my coefficients. So step 1 is to set it up. Step 2, and that's with putting your binomials and then putting your signs inside. Step 2 is to look for factors. So here, how I've got 21, that I can have 21 and 1, or I can have 7 and 3. Now, I know my biggest number is going to be positive, so I'm going to put a positive here, and I know my smallest number has to be negative. So when I do 21 minus 1, I get 20, but I'm trying to get the 4. When I get positive 7 minus 3, that gives me positive 4. So this is the pair I want. So now I'm going to do m plus 7 and m minus 3. Now, here is a hint. When you do this, almost always for this unit, see how right here it says m plus 7? Look at here, it says m plus 7. Almost always, you know one of the things that you need to divide out is going to be there. You can just use the diamond method. I don't feel confident enough to go over how to do the diamond method, but that is another way you can do it. Absolutely. So then what we have is, now that we've done our factoring, we can divide these out to get 1. So I'm going to be left with 1 in the numerator and m minus 3 in the denominator. If we look here, you can do the diamond method again. I think you do like 6 here and you're trying to get 5. Is that how you do the diamond method? And then we know that I do it that we know that this is positive. So both of the signs are going to be the same. And they're both going to be whatever this is. So right away, I know both of these numbers have to be positive. So then I either have 1 and 6 or 3 and 2. Well, 1 plus 6 is 7, so it can't be that pair. So it's got to be 3 plus 2. And then I write this down. Now, here's the catch though. 3 plus 2, when we add it, oh, I did that backwards. See, that's what I tell you. My bad. Hold on. I put the 5 and 6 in the wrong place, I think. 5 goes on the top, 6 goes on the bottom. So you've got 1 and 5, and that's it. 1 and 5 is the only one. See, I screwed that one up. It's all right, growth mindset. So now we have n plus 1, n plus 5. And then it makes sense because look at n plus 1's in the denominator. So that makes sense for that. So when I do n plus 1 in the numerator, n plus 5 in the denominator, and divide out the n plus 1's, these reduce. So that leaves my answer as n plus 5. Okay, so you can do the diamond method. Like I said, I'm not, obviously, as I just showed you, that comfortable with that method. All right. Then you're going to possibly see questions that take it a little bit farther than that. So this is a little bit more challenging here. All right, I'm going to throw this in the middle so I can put things above and below. Whenever you have 2 trinomials that you have to factor, for me, it's easier to factor the one that seems more simple. And to me, the numerator in this case is the one that's easier to factor. And again, the reason why I do that is because that is going to be the foundation for what I have to do in the denominator. So here, let's see, they have to multiply to 4 and add to 5. So I either have 1 and 4 or 2 and 2. Well, 1 plus 4 is 5. So this is the pair that I need. So up here I have a plus 1 and a plus 4. Again, my method says these are positive, so they're both going to be the same. And then I know that because they're going to be the same, they're both going to be positive. That's how I set it up. When we do our denominator, we know that one of the factors most likely has got to be a plus 4. So when we do that to test it, let's throw a plus 4 here. Well, we know it's got to be 20 here and 9 here, and we're hypothesizing one of the numbers is 4. Well, what 20 divided by 4, what does that leave us with? 5. And when we add 4 plus 5, then we have it. So some kids who struggle with factoring, if you can factor the easy trinomial first, that might help you to figure out what you need for the second one. Because the other one we could have done, if we thought, well, could it be the 1 here? Well, 1 and 20 gives you 21, not 9. So that's why we can eliminate that one. So that's why I factor the one that looks easy, and then you can eliminate from there. After we've done the elimination, a plus 4 divided by a plus 4 leaves us with 1. So this answer is a plus 1 over a plus 5. And then that's it. Do not cross out the a's. It's just one step at a time, and then leave it. Okay, let's look at a different one. Okay, another thing you might have to do is you might have to flip the fraction. So I'm going to show you a really bizarro one right here. Let's take a look at this one. Here we see the divide symbol. Anytime you have the divide symbol, we know that we have to flip the fraction or multiply by the reciprocal. Anytime you see divide, then you need to multiply by the reciprocal. So the first thing I tell my students to do is right away rewrite everything. So the first fraction stays exactly the same with no changes. Then this becomes a multiplication sign, and then we flip the fraction. Then it goes back to elimination again. It's just one long multiplication problem. Here's v plus 8, here's v plus 8. These each become 1 because any number divided by itself is 1. Even though v plus 8 doesn't look like a number, it's still like 2 plus 8 is, if v was 2, it'd be 10 divided by 10. If v was 20, it'd be 28 divided by 28. Regardless, it becomes 1. Here also, we can cancel these fractions out. So we're going to be left with v minus 7 in the numerator. And we're going to be left with 1 in the denominator, which we know just will leave us with that fraction. Okay, let's look at another one. All right, here's a funkity-dunkity one. This one already has it set up as a multiplication problem, but notice how the b's are kind of out of order. So what I'm going to do first is I'm going to rearrange the b. So I'm going to write sugar. I'm going to write negative 7b plus 28. Because all that did is I switched the order and put the variable first. Now I notice in the denominator I have a b minus 4. So most likely in the numerator I'm going to get a b minus 4. Well, how do I do that? Well, if I'm trying to get a negative 4, 28 divided by 7 is going to give me 4, but because I'm switching the signs, I'm actually dividing by negative 7. So each of these gets divided by negative 7. And that will allow me to have negative 7 outside and the b minus 4 is the inside. So now I can go back to my canceling, just like we've done before. Here's b minus 4, that cancels with this one. So over here I'm left with negative 7. And I'm just rewriting it like this. I notice there's nothing else that can be canceled. So negative 7 times 1 is negative 7. 1 times b plus 10 is b plus 10. So for the most part, let's just do 2 more ugly ones and then I'll show you adding. Okay, here's some ugly ones. First, I look for the greatest common factor. I see that this first one, whoops. Oh, I'm glad. Yay. I see that this first one has an x squared and an x. So let's just deal with that first. Because they both have an x, I'm going to pull that x out because that's what they have in common. So I'm going to put an x here. Well, what else do they have? Well, I notice that they also have the 10 in common because I know that 10 times 1 is 10. And I know that 10 times 2 is 20. So because in both cases, they both have 10s in them, I also am going to pull out the 10. And so what you can do is some kids like to do this. Some kids like to write 10x squared and then just put 10x underneath it to cancel it. Some kids doing it this way with like a ton of scrap paper is what's best for them. So if that's you, go for it. You can totally do it that way. So now I can see that 10 divided by 10 is 1. And I know that this is really 2 x's and this is 1x. So I can just cancel this x out and this x out. And so all I'm left with inside is x. Same thing here. 10 can go into 22 times, and the x's cancel. So when I pull out that 10x GCF, I'm left with the x minus 2. We got to do the same thing. Every single one of these, we're going to pull out what do they have in common. So now I see that this is a 40 and this is an 80. And I see that we again have the x squared and the x cubed. So then we're going to do it step by step again. Well, I know 40 times 1 is 40. And I know that 40 times 2 equals 80. So that means that I can just put my 40 outside. And since I know that 40 divided times 1 is 40, I can kind of put an imaginary 1 here. The subtraction sign stays the same. Since I know 40 times 2 is 80, well, here's my 40, so I have to put a 2 here. Then I look at my x's. Well, I have x cubed, which really is equal to 3x's, divided by x squared, which is really equal to 2x's. So I notice that I can pull 2x squared, or an x squared out. I can pull out 2x's. So that leaves me with 1x right here, and then the minus 2, there's no x's left over here. So again, that's just another way to show you how you can factor. But we're not done yet. We only did half the problem. We're not even there. So far, we got to just keep plugging along. Now we see, what do we have here? Well, here we have a 16. Here we have an 80. And then we have our x cubed and our x squared. So we got to keep plugging away. Well, I know that 16 can be 1 times 16. But 16, 503. Ooh, 16 can go into 85 times. Okay. So what that means is I know I can pull the 16 outside. So I'm going to do that. 16 comes on the outside. So when I do it, I have the 1 left here. Let's put a plus sign. And I have a 5 left here. So now I've taken care of the numbers. Well, just like we did before, we see this is 3x's and this is 2x's. So I notice the smaller number is x squared. So I'm putting my x squared outside. So I've got 3x's and I'm taking out 2x's, so that means 1x is left. Here I have 2x's, I'm taking out 2x's, so I don't have anything left. So that part's done. Now we're on our last one. We've got a 6x. Well, there's no x's, but I know that 6 and 30 have something in common, so I can pull that out. So I'm going to pull out my 6 on the outside. And when I do that, I know I'm left with x, and then I know that 6 times 5 is going to give me 30. So I'm going to put 5 here. Now that I've done all of that crazy hard work, now I'm looking for what they have in common. So I'm going to say, well, here's an x minus 2. Here's an x minus 2. I can cross those out because you can cancel up and down or diagonally. You never can cancel across. Only up and down and diagonally. So here I see I have an x plus 5 and an x plus 5. So I can cancel those out. I also see that I have an x squared here and I can cross out diagonally. So I have an x squared here. So I can cancel those out. I see I have a 10 here. Well, I know 10 can go into 40 4 times. So I'm going to take this 40 and make it a 4. So now I think that's pretty much it. Oh, we can still do 2. Oh, 4 can go into 16 4 times. So we can cancel that out. And I know 6 is really 2 times 3. And 2 can go into 4 2 times, so I can cancel that out. That's why I love these problems, honestly, because it's literally, once you do the hard work of breaking everything out, it's super easy. It's like getting rid of all the junk in your life. So then I see, what did I not cancel out? Well, I didn't cancel out the x. I didn't cancel out the 2. Everything else in the numerator got canceled out. And in the denominator, everything got canceled out except this 3. So that means my answer is x times 2 divided by 3, which we would just rewrite to 2x divided by 3. Let me make sure I did that one right, because that was a lot. Yep, That was it. So it's really just taking one step at a time and breaking it down. Let me show you. You are going to see addition and subtraction. So let me just look a problem up for you. So that we can do that. Okay. All right, let's take a look at this problem. Let's do like 3 more problems and then I'll be done with this video. Okay, this problem I wanted to show you first because even though it's a little bit blurry, let's take a look at the denominator. Do you notice how the denominator is the same in both of these? It's x plus 5, and it's x minus 3, x minus 3. So because those denominators are the same, it's just like you did fractions back in the day when you were in like 3rd grade. Remember when we had 2/5 plus 1/5? What did we do? First, we had the same denominator. And then the second thing you did is you add the numerators. So that method you learn in 3rd grade still works now. So do we have the same denominators? Yes, we have x plus 5 and x minus 3. So that's going to be my denominator. Now we need to combine the numerators. So what I'm going to do is I'm going to write 2x plus 7. But watch this. I'm going to put the x plus 10 in parentheses for the subtraction. This is where kids are going to mess up. They're going to forget to put the parentheses around the x plus 10, and that's going to screw you up because you have to distribute that negative. So what's going to happen is this negative is really subtracting this whole thing. So really, this becomes a positive, this becomes a negative, and this becomes a negative. Because what I'm doing is I'm really saying, well, what's negative 1 times x? Well, that's negative x. What's negative 1 times 10? Negative 10. After you've done that, it's just simplifying. That's it. I notice I have 2x here and I have a negative x here. So 2x minus 1x is x. It's kind of like you have $2 minus $1. You're left with $1. So this is just going to be plain old x. Then I have positive 7 and negative 10. Well, if you have $7 and you want to buy something for $10, you still need subtract $3. Now, I'm not done yet because look what happened. And this is going to probably happen a bunch. Notice how this says x minus 3 and this says x minus 3. So because of that, I can cancel this entire numerator with the x minus 3 in the denominator. Well, when we cancel, really all we're doing is writing 1. So my final answer is 1 over x plus 5. Let's do another one. Let's do one that's not as pretty. Ooh, this one's really ugly. Good, 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 good. Okay. So this is showing you how to solve it, but let me just real quick delete the answer so you can see, so you can learn how to do it. Okay, so here's our problem to start. The first thing we got to do is make everything look pretty. Okay, so we're going to go back and just do this step by step. First, I notice this says x minus 3, and this is 9 minus x squared. So when I factor this out, this is really going to stay x minus 3 for right now. This is really x, sugar shoots. This is really 3 plus x times 3 minus x. And really, what I want you to do is I want you to think of difference of two squares. Remember when you had this, what we did is you immediately was like, okay, x, and then you took the square root of 9, 3, 3, and then we had one the same and one different. That's the same thing here. The difference is when it says 9 minus x squared, it's that first we take the square root of 9, and then we take the square root of x squared. That's why it's looking like this. I would be astounded if Coach Emmons and Miss Kendry and Jones and everyone gives you a question this hard. So I'm showing you a really hard question. So if you understand this only 70%, you're going to be okay. All right. So notice how I have an x minus 3 here, but I don't have an x minus 3 over here. So that's when I got to be sneaky. And I'm going to actually say, you know what? I'm going to rewrite this to be x plus 3. But that still doesn't help me. And then if I rewrite this, this is going to be negative x plus 3. Well, I know I don't like to have negatives next to the x, so this is where the sneaky part comes in. You take it out. All we're going to do is divide each one of these things by negative 1. So this is really going to leave me with negative 1 times x plus 3. Well, these cancel, so I'm left with positive x. And 3 divided by negative 1 is negative 3. And then look what happens. Now, here's my negative 3. Here's my negative 3. So I can keep going with this problem. So now I've got 8x here. And then here I've got x minus 3. I'm going to leave a space. Here I've got 5. And then here I've got this really ugly thing. I've got negative 1 times x plus 3 times x minus 3. So I got to think, okay, what am I missing? Well, over here I've got x minus 3, x minus 3. So what I'm missing is this part right here. So that's what I have to put into this silly little hidden fraction. And basically, as ugly as it is, all I'm doing is multiplying by 1. Even though it just looks ugly, because like 5 divided by 5 is 1, 10 divided by 10 is 1, negative 1 times the quantity x plus 3 divided by negative 1 times the quantity x plus 3. So ugly divided by ugly, still get 1. That's what this is. So now I can combine and be like, dude, now I have all the same denominator. So I'm chilling. So my denominator is going to be negative 1 times x plus 3 times x minus 3. And I got that from multiplying all this together. And now I have the same denominators, like if I was doing 3 and 3, just combine them up. Now I got to do my numerator. My numerator says, okay, take 8x, multiply it by negative 1, multiply it by x plus 3. And then all of that is plus 5. So now I just got to do the math. That's it. Here, I notice that I've got 8 times negative 1 is going to leave me with negative 8x times x plus 3. And then I have my plus 5. So I just keep simplifying it. Well, negative 8x times x plus 3, I can distribute. This is going to be negative 8x squared. Negative 8x times positive 3 is negative 24x. And then I've got that positive 5. So that's going to be my ugly, ugly numerator. Where's my mousers? Okay. And then now that you've had your ugly, ugly numerator, then we have that denominator. Which we had before. Now, one thing that some people are going to say is they're going to be like, dude, you can't have a negative in the denominator. And they're technically right. So all we're going to do is cross this baby out and then change all these signs. So the final answer will be x squared plus 24x minus 5 divided by x plus 3, x minus 3. Okay, so this is kind of essentially what you can expect to see on your test or your quiz. I haven't seen the quiz, but I have seen the work that Emmons did to help get you prepared. So if I were you, thank you so much for signing on. A couple people stayed on the whole time. My best recommendation to you is watch what Coach Emmons did. So if we go real quick, I'll pop it up so you can see it. So if you pop into gwinnettmath.com, I always put the most recent recording on the homepage so you don't have to look for it. So for this case, you would go down to Algebra 2, and the most recent recording right now is from Coach Emmons. So you could just watch her 15-minute video, and she's going to go through and show you how to do it. So I would say that's where you really should look because she's going through the worksheet and the learning target check. The other thing you can do is up here at top, it says Algebra 2. So when you click on Algebra 2, that's going to take you to all of the videos. So previous videos that I've done, all Coach Emmons videos, and then this video is going to go there. So that's pretty much it. Thank you so much for participating and watching. I hope this helps. I will catch you guys later at school. So that's it. Good night.